Today we're going to look at solving systems of polar equations. And just as you did with your rectangular coordinates, we can apply those same techniques that you solved systems of equations back then with polar. So think back what you did with rectangular coordinates. Typically what you did is you did a couple of things. If I had two lines that intersected, I knew a solution point was right there at the intersection of the 2 points. I was also able to do substitution, elimination, as I mentioned, the graphical intersection, and all the different things with matrices in order to solve. We're going to do this one of two ways. We're going to look from the graphical perspective and the algebraic perspective, specifically a substitution perspective. So we're going to start by finding out my angle measurements and my R values for the points of intersections of polar graphs. So starting off, we've got the graphs of r equals 1 and r equals 2 cosine theta. And I want to find the intersection of these two graphs and write the answer as an ordered pair. So let's start by graphing each of these pieces. First of all, r equals 1. That is a circle with radius 1 centered at the origin, or at the pole in polar coordinates. The second one, r equals 2 cosine theta, that's a circle with diameter 2 along the x-axis. So this one's got a diameter of 2, which means we've got a radius of 1. That's an approximate picture of what we've got. And I want to find the points of intersection, because the points of intersection are what are going to solve the equation. So I've got a point of intersection right there, a point of intersection right there, and what are those points? Well, I've got the equation r equals 1, r equals 2 cosine theta. And let's do substitution. Here I know r equals 1, so let's plug in 1 into the second equation. 1 equals 2 cosine of theta. So the cosine of theta is 1/2. To solve for theta then, we take the arc cosine to both sides. And the arc cosine of 1/2 is pi over 3 and 5 pi over 3. So those are the angle measurements. Now I would like the ordered pair. And we know each of the ordered pairs are in r theta format in polar coordinates. Well, I know my thetas here are pi over 3 and 5 pi over 3. What's my r value? And what we would do is we go back and look at our original equations and substitute in. Now the easy one here is to say r is equal to 1, and then we're done with it. But if I didn't have such a clean equation where it doesn't jump out at me that r equals 1, I could choose any equation, substitute in the answers I got, and then solve. So let's say I did it with r equals 2 cosine theta. I would have plugged in pi over 3 and 5 pi over 3 into my equation. The cosine of pi over 3 is 1/2. The cosine of 5 pi over 3 is 1/2. So when I simplify it down, I get r is equal to 1. So same thought process you used before. Take your answer you get, plug it back into your original equation, and then you can get your ordered pairs. Now the question sometimes emerges, how do we know where we want to restrict our answers to? Typically it was always 0 to 2 pi. But you know from the beginning of section 9.7, you don't need 0 to 2 pi to get the full picture. For example here, 2 cosine theta, all I need is 0 to pi to get the full picture. And the answer is, for this, how do we want to restrict our answers? We want to go as far as it takes to draw the complete graph once. If I look at r equals 2 cosine theta, I can draw the complete graph in 0 to 2 or 0 to pi. Here though, with r equals 1, I need 0 to 2 pi in order to get the full picture. So I've got to go with 0 to 2 pi for both of them in order to get the full picture. You've got to take whatever domain is going to produce the full picture, and that's the one that you are going to work with.